chemical equilibrium part is over. The next part is ionic equilibrium. So as the name implies, ionic equilibrium means when you put any salt inside the solution and if some portion of the salt gets dissociated into ions, then after some time there exists an equilibrium between the salt and its ions. So that is referred to as ionic equilibrium. So ions in equilibrium is referred to as ionic equilibrium. So to start away with, we will first talk about electrolytes, the definition of electrolytes. What are electrolytes? So just now, as I said, that there are some substances which dissociate into ions in water and they are called electrolytes. And why they are called electrolytes? Because of the presence of the ions. As ions are carriers of charges, so they are actually responsible for conduction of electricity. The substances that dissociate into ions when dissolved in water, the substances that dissociate into ions when dissolved in water are called electrolytes. Such substances conduct electricity in aqueous solution. Why do they conduct electricity in aqueous solution? Because they break down into ions, and ions are actually responsible for the conduction of electricity. Now, electrolytes are further classified into two types depending upon the extent of dissociation. Kiman khini dissociate korea se. So based on that, they are further classified into two types. One of which is called strong electrolyte and the other is weak electrolyte. So on the basis of how much dissociation is going on, I can further subdivide the electrolytes into two types, strong and weak. What are strong electrolytes? Strong electrolytes are those which dissociate almost completely. Gutekhini bhangi jay ion chole. And weak electrolytes are those which dissociate only to small extent. Only a small fraction of it undergoes dissociation. Gutekhini dissociates nohoy. Now, out of the two types, where can you expect equilibrium? Obviously, the weak electrolytes, because when small portion of it gets dissociated and thereafter an equilibrium is achieved. So obviously equilibrium topic or it is the weak electrolytes which are important to us. Tell me after you have completed so that we can proceed further. So it's a very, very important topic. Strong and weak electrolytes. Oh yeah, can I proceed? All of you have written?
Yes, sir.
Okay. So how many types of electrolytes are there on the basis of the extent of dissociation? 2 types. What are they? Strong electrolytes and weak electrolytes. So we are going to discuss in details about the strong electrolytes first. So strong electrolyte or বিষয়ে আমি discuss করু। Number A, strong electrolytes. These are dissociated almost 100% or completely. গোটেইখিনিয়ে প্ৰায় dissociate কৰে যিমানখিনি লৈছা almost the whole of the molecule are getting dissociated into ions. Consequently, they are very good conductors of electricity. Consequently, they are very good conductors of electricity. Why? Obviously, because conductance depends upon the ions present in the solution. And if the molecules dissociate almost completely into ions, so larger will be the number of ions. And therefore, they are very good conductors of electricity. As for example, sodium chloride, H2SO4, HNO3, NaOH, etc. So when you are showing the breaking or dissociation of such substances, suppose I put sodium chloride in aqueous solution. So you are supposed to show them with a single-headed arrow, suggesting that they completely dissociate into ions. H2SO4, say for example, in aqueous solution, will almost completely dissociate into ions to give H plus and sulfate ion. Likewise, sodium hydroxide in aqueous solution will completely break down to give Na plus OH minus. Okay, so this way, You see that I am putting a single-headed arrow when I want to show dissociation of such substances. They may be acids, they may be bases, or they may be salts. But what is common between all of them is all of them are completely getting dissociated into ions. So whatever is the number of moles of the substance you are taking, it is proportionally breaking down to the respective ions. The ratio of the molecule is to ions will always be a whole number. Say, for example, sodium chloride. The number of moles of sodium chloride, if you take it as 1 mole, then these two will be also in 1 moles. If you take H2SO4 to be 1 mole, then H plus will be 2 moles, sulfate will be 1 mole. So likewise, the ratio of the number of moles getting produced will be same as it is visible. Understood?
Yes, sir.
Can I rub it and proceed to the next type of electrolyte?
Yes, sir.
Okay. So the second type of electrolyte in the row is weak electrolyte. So it is the weak electrolytes which are important to us because it is these electrolytes that very soon attain equilibrium between dissociated and undissociated substances. Such substances never get completely dissociated. Completely কেতিয়াও dissociate নহয় under ordinary conditions. কিমানখিনি dissociate হ'ব যাতে আমি তাক weak electrolyte বুলি কওঁ? Less than 5%. Okay, so they dissociate into solution to such a small extent they dissociate to a very small extent less than 5%, as a result of which they are poor conductors of electricity. Now, if they dissociate poorly or incompletely, the ions present will be less. And if ions present are less, automatically their conductance will decrease. As for example, CH3COOH, NH4OH, hydrogen cyanide, etc. Now, how do I show or represent the weak electrolytes? We show the dissociation of weak electrolytes with the help of reversible sign. With the help of reversible sign. And what is the meaning of the term reversible sign? It means that not the whole of the molecule is getting dissociated, only a fraction of it is getting dissociated. So CH3COH, acetic acid, it's a weak acid. Similarly, NH4OH is a weak base. So whenever I want to show the dissociation of such kind of acid or base, you are always going to show a reversible sign. And with the help of this sign, you can easily make out whether the given electrolyte is weak or strong. Is it clear? Is it understood? Weak or strong to keneke gom pam?
Can you please explain once, sir?
Okay. If you look at the sign, is it a single-headed arrow or double-headed arrow?
Double-headed.
Now, what's the meaning of the term double-headed arrow? It means that only a small fraction of it is getting dissociated into ions, because initially, when it is breaking down into ions, the ions will have again the tendency to combine back to give you the original molecule. So because the process is going in both the directions, so therefore we call this particular type of process reversible process. Understood? So reversible hole ki hobo? Reversible hole gute molecule to dissociate nohoy. Okay, so completely dissociate nohoy, only a fraction of it is getting dissociated. Understood?
Yes, sir.
Suppose you take 100 moles. Out of 100 moles, only say 5 moles or 4 moles or 3 moles dissociate into ions. The rest, 95 or whatever is left out, will remain undissociated. So ions produced are very less in number. And because the ions produced are very less in number, so therefore the conduction is also very poor. Clear?
Yes, sir.
So etia out of the strong electrolyte and weak electrolytes that we have discussed just now, because weak electrolyte is not getting dissociated completely, so therefore we will be using the concept of degree of dissociation or ionization. That means what fraction or what percentage of the molecule is getting dissociated. Because as far as the strong electrolytes are concerned, there is no problem. It is getting dissociated 100%. Jiman khini molecule loisila gute khiniye dissociate hoye ase. Gotike tat ami degree of dissociation term to include nokoru. Kyo nokoru? Karon 100% jodi dissociation hoy, tetia hole degree of dissociation to 1 hobo. Kintu jodi ami weak electrolyte or khetor discuss kori asu, so the percentage is very poor. As I just now said, that it is less than that of 5%. So what fraction of the molecule is actually getting dissociated is calculated on the basis of degree of dissociation. So whenever we talk about this degree of dissociation, ami agoteo paisilu when we were talking about type 3 reaction, in order to get the Kp and Kc expression, এতিয়াও আমি পাইছিলো. So here we are going to get it again. So write down the topic degree of dissociation বা ionization. Degree of dissociation বা ionization. In the solutions of weak electrolytes, an equilibrium is established between the ions and unionized electrolytes. Okay, so when you take a weak electrolyte, as I said that the molecule is going to get dissociated into ions to a very small fraction and equilibrium is established. When equilibrium is established, you have both undissociated molecule as well as the ions produced from them. And this type of equilibrium, such an equilibrium is called ionic equilibrium. Such an equilibrium is called ionic equilibrium. Suppose we have a weak electrolyte, AB, which dissociates incompletely to give A plus plus B minus. So you will see that after AB breaks or dissociates to some extent, there is an equilibrium established. And once equilibrium is established, you will have this molecule also present. It is undissociated molecule and ions also present. So it is the equilibrium that is established between the undissociated molecules and the ions, which is called ionic equilibrium. The equilibrium established between AB, A plus and B minus, where AB is undissociated molecule, A plus and B minus are the ions produced, is called ionic equilibrium. The fraction of total number of molecules that undergo dissociation is called degree of dissociation, which is defined as alpha or which is denoted as alpha. তার মানে গুটে AB জিমানখিনি তুমি দিছা, out of the total AB, what fraction of AB is getting dissociated, that is referred to as the degree of dissociation. So if you need to define the alpha in terms of the expression, so what we can write is alpha is the ratio of how many ions are produced. Therefore, alpha is equal to number of moles of electrolytes ionized কিমান কেটা ভাঙ্গিছে out of total number of moles of electrolytes dissolved. তুমি কিমানখিনি ইলেক্ট্ৰোলাইট ইনিশিয়ালি আছিল and তাৰ পৰা কিমানখিনি ভাঙিছে এই ৰেশিওক আমি ডিগ্ৰী অফ আয়নাইজেশন বুলি কওঁ. This ratio is referred to as degree of ionization. Degree of ionization within bracket alpha increases with dilution. You know what is dilution? Dilution means addition of more water, more solvent. So যিমানে এটা weak electrolyte তুমি solvent বেছিকৈ add কৰি থাকিবা, the more you add solvent, it is found that its degree of dissociation keeps on increasing. That means more and more molecules ionize. The extent of ionization also depends upon the strength of the bond. How strong is the bond? If the bond is strong, then obviously its dissociation will be poorer. If the bond is relatively weaker, so it is going to dissociate more easily. Okay? Have you understood the meaning of degree of dissociation?
Yes, sir.
So in a school, suppose the school is a very good school and almost all the students every year pass out with good marks. So out of 200 students who appeared for the exams, if the whole of the students are getting passed, so obviously we say that the fraction of students getting passed is 1. Why is it 1? Because the ratio of number of students passed divided by the total number of students appeared are same. So obviously the ratio, if both of them are same, numerator and denominator both are same, so the ratio will come out to be 1 or 100%. But what if the school's performance is not up to the mark? Out of 200, say only 10 students passed. In that case, the fraction of students passing will be 10 out of 200, isn't it? So weak electrolyte karone ami degree of dissociation term to introduce korisu. Stronger karone degree of dissociation has no significance. Is it clear to all? Bhumika, Kaushik?
Yes, sir.
Okay.
Yes, sir.
So after discussion of the different types of electrolytes and after learning that because the chapter is dealing with equilibrium, so it is always the weak electrolytes that attain equilibrium. Strong electrolytes never get equilibrium as they are irreversible or irreversibly breaking down into ions. Ions don't have any tendency of combining to give you back the molecule. So the next thing that we are going to discuss is acids and bases. acids and bases. So from time to time, different definitions of acids and bases were given. So that we need to understand. So basically, according to our syllabus, we are going to discuss 3 different types of definitions of acids and bases. The first definition is called Arrhenius concept. Okay, so according to Arrhenius definition, what is an acid and what is a base? So let us try to understand. According to Arrhenius concept, according to this concept, acids produce H plus ions in aqueous solution. So all those substances that can dissociate to produce H plus ions in aqueous solution are referred to as Arrhenius acids. And generally they are represented as Ha, because Ha is capable of losing H plus ions. So any substance that is capable of donating H plus ions, liberating H plus ions in aqueous solution will be called as an acid. Say for example, HCl. That breaks down to give H plus and Cl minus. HNO3. So I am supposed to give a single-headed arrow because it is a strong acid. HNO3, H plus NO3 minus. But when we talk about weak acids like acetic acid, CH3COOH, then we are going to put a reversible sign, and the concept of equilibrium will come in the last expression. Now, what is a common between all the 3? What is a common thing between all the 3 molecules?
Sir, H plus ion is dissociated.
So all of them are producing H plus ions in aqueous solution. And because all of them are capacious of donating H plus ions in aqueous solution, so all will be called as an acid. But within them, what is the difference? Whereas the first 2 acids are completely dissociated, so H plus ions produced will be very large in number. And therefore, HCl and HNO3 are examples of strong acids. But CH3COH is an example of weak acid. Understood?
Yes, sir.
Yes, sir.
So out of all these 3 examples, in which one of them you are going to apply the concept of degree of dissociation?
Acetic acid.
Acetic acid. Okay, so degree of dissociation concept is applicable only to weak electrolytes, and weak acids are weak electrolytes. So because the whole of CH3COH is not getting dissociated, only a fraction of it is getting dissociated. So we say that degree of dissociation will be applicable to the weak acid. Number of H plus ions delivered by an acid number of H plus ions delivered by an acid in aqueous solution is called basicity or protosity of the acid. Where from the term protosity has come? See, H plus is also called as proton, because if you remove one electron from hydrogen atom, then it is left with only one proton. So because every acid is releasing a proton, and depending upon how many H plus ions can be released, so that is called its protosity or basicity of an acid. So HCl is a monoprotic acid. Why? Because it is liberating only one proton. HNO3 is also monoprotic acid, but H2SO4 is capable of giving away two H plus ions, and therefore we call H2SO4 as a diprotic acid. So depending upon number of H plus ions that can be donated by an acid, we use the protosity term accordingly. Okay, is it clear?
Sir, can you explain again?
HCl এ কিমানটা H plus লুজ কৰি আছে H plus ions এটা নহয় জানো
Yes, sir.
তো তেতিয়া আমি তাক কম যে তার protosity টো হল 1. It is a monoprotic acid. তো per molecule কিমানটা আয়ন প্রডিউস কৰি আছে যদি এটাই কৰি আছে it will be called monoprotic. H2SO4 যেনেকে if you break down H2SO4, how many H plus ions will be given by H2SO4? 2 H plus ions, isn't it?
Yes.
গতিকে H2SO4 আমি কি বলি কম diprotic acid. So depending upon how many H plus ions are given, one H plus যদি লুজ করে ইয়াত দুটা এক্সাম্পলতে 1 1 লুজ কৰি আছে গতিকে আমি তাক monoprotic acid বুলি কম যদি দুটা H plus লুজ করে diprotic তিনিটা কৰিলে triprotic likewise ঠিক আছে
Yes, sir.
okay so protosity depends upon how many protons per molecule are produced. Can I rub it and define base according to Arrhenius concept?
Yes, sir.
Okay. So ইয়াত মই just acidor definition to দিছো. Now we are going to discuss the definition of a base. So acid এ যদি H plus lose করে তেতিয়া base এ কি lose কৰিব according to Arrhenius concept? Base is a substance that produces OH minus ions in aqueous solution. Base is a substance that produces OH minus ions in aqueous solution. The same way, if you have a base, it will be generalized by the expression BOH, as it is capable of liberating OH minus ions. Okay, so this is just a general expression. It's not any particular base. Kintu jikuno base according to Arrhenius concept, I can represent it as BOH so that it can liberate OH minus ions. And further, depending upon how it is getting dissociated, suppose it is sodium hydroxide. It's a strong base. So I'm going to put a single-headed arrow. Okay, so there is no question of degree of dissociation because it is completely dissociated into ions. But if I take ammonium hydroxide, which will irreversibly break down, or which will reversibly break down, sorry. So it's a weak base. The moment we see an equilibrium sign, that means it is a weak counterpart. So just as the acids were capable of donating H plus ions, the bases are capable of donating OH minus ions. The number of OH minus ions that can be donated by a base is called its acidity. उल्टा हो जाए, base और acidity strength determine करा है आरु acid और basicity strength. तो NaOH of course is a mono acidic base. Why it is called monoacidic base? Because it can lose only one OH minus ions. Magnesium hydroxide. What is the formula for magnesium hydroxide? Mg within bracket OH whole 2. So it can liberate two OH minus ions. So we will call it as diacidic base. So H plus ion lose করার tendency কোয়া হয় basicity. আর OH minus ions lose করার capacity আমি acidity বলি। তো base or acidity আর acid or basicity compare করা। হয়েছে?
Yes.
Now there are some substances which can both act as an acid as well as a base. এটা ধরো water. Water যদি আমি consider করুম তার নিজর সলিউশনতে it will dissociate to give H plus as well as OH minus. গটিকে water can act both as an acid as well as a base. So such type of substances that can furnish, that can give away both H plus and OH minus ions in aqueous solution are called amphoteric substances. The substances that can furnish both H plus and OH minus ions in aqueous solution are called amphoteric substances. Are called amphoteric substances. As for example, water. So if you look at molecule of water, it is going to give us both H plus as well as OH minus. So H plus দিয়ে আরো OH minus ions দিয়ে. Whereas H plus is proton, OH minus is called hydroxyl ion. Okay. So the substances that can donate both H plus and OH minus ions are called what? Amphoteric substances. Clear or not?
Yes, sir.
So according to Arrhenius concept, just now as we discussed, acids donate H plus ions, bases donate OH minus ions. And depending upon how much of dissociation is going on, the acids are further categorized into strong acids and weak acids, and bases are also categorized into strong bases and weak bases. But irrespective of whether they are strong or weak, the common definition for both acid and base is acids are proton donors and bases are hydroxyl ion donors. Understood up to this much?
Yes, sir.
Sir.
Okay. So it is the oldest definition of acids and bases. Oldest definition of acids and bases. So after Arrhenius concept, because it had some limitations. So in what way it had limitations? It had limitations, suppose it was restricted to only certain molecules. If you have hydroxyl ion, then only you will be called as a base. And if you have a proton, then only you will be called as an acid, isn't it? But if you don't have OH minus ions, then you cannot be called as base. But there are certain substances which are found to behave like a base, even though it doesn't have OH minus. Suppose we have NH3, ammonia. So ammonia shows all the characteristic of a base, but it cannot be called as Arrhenius base. Why? Because ammonia doesn't have OH minus ions. Tarmane, the definition of Arrhenius acids and bases were restricted to very small number of molecules. And that is why it had limitations. So therefore, the next concept called Bronsted Lowry concept. Bronsted Lowry concept was introduced. Bronsted Lowry concept was introduced. So let us first of all try to understand the definition according to Bronsted Lowry concept. What is an acid and what is a base? According to this concept, acids are proton donors. So nothing new. In Arrhenius concept also, acids were considered to be proton donors, proton means H plus, whereas bases are proton acceptors, whereas bases are proton acceptors. Now, altogether a different definition was given to a base. So bases are proton acceptors. So anybody who can accept H plus ions will be called a base, and anybody who can donate H plus ions will be called as an acid. Say for example, when we take ammonia and water, so it has been found out that when ammonia and water are taken, then water has the tendency of donating H plus ions to ammonia, and ammonia has the tendency of accepting H plus ions from water. Now, if ammonia accepts H plus then it will be converted to ammonium ion. And water will be getting converted to OH minus after donating H plus. So hence we can say that this is getting converted to NH4 plus and this is getting converted to OH minus. What is ammonia doing? It is adding proton. So when ammonia is added up with a proton, it is converted to ammonium ion. And what is water doing? Loses proton. So if it is so, then we can write that the behavior of ammonia in this combination is a base because it is accepting or adding proton. And behavior of water is an acid. Now, if you look at the products which are formed after gaining H plus or losing H plus, what is the behavior of NH4 plus? Tell me. NH4 plus, what it can do? Can it lose proton or can it further gain proton?
Lose proton.
It can lose proton because it has an extra H plus, and because it can lose proton, so it will be acting as an acid, and therefore we call this as an conjugate acid. Conjugate acid. Car conjugate acid? Ammonia or conjugate acid. Acha. What OH minus can do? Tell me.
Accept
OH
proton.
minus accept koribo pare proton, and accept korile tak base boli koa hobo. So here I will call it as conjugate base. Car conjugate base core pra hi produce hoise water. So ei je pair ami ulalu NH3 comma NH4 plus H2O comma OH minus. These pairs are referred to as conjugate acid base pairs. Conjugate acid base pairs. So the conjugate acid base pairs differ from each other by a proton. NH3 aru NH4 plus or mazor difference to hole eta proton. ঠিক তেনেকুৱাকে H2O আৰু OH minus ion মাজত difference to hole eta proton. So in this pair, the one which has more proton in it will be called as an acid, and the other which has lesser proton in it will be called as a base. And the pairs are referred to as conjugate acid base pairs. So what is the definition of conjugate acid base pairs? The acid base pair which differ by a proton are called conjugate acid base pair. তো এটা সাবস্টেন্স যিকোনো আয়ন বা মলিকিউল যদি তোমাক দিয়া থাকে and you are asked to write its conjugate acid and conjugate base, how you are going to do it? Suppose you have a substance and the substance can be a molecule or ion. So if you add H plus to it, Okay, extra jodi tumi eta extra H plus tak di dia, then it will be converted to its conjugate acid. আর যদি এই সাবস্টেন্সৰ পৰা proton eta গুছাই দিয়া, if you remove a proton out of it, proton eta কমি যায়, তেতিয়া হলে it will be called as conjugate base. তো সব সাবস্টেন্সৰে simultaneous conjugate acid conjugate base নাথাকিবও পাৰে, কিন্তু যদি থাকে তার মানে the substance will be called as an amphoteric substance. The substance will be called as amphoteric substance. Suppose water. What is conjugate acid of water? Jodi amak khude, so add a proton to it. So what will be the substance formed? What will be the ion produced when a proton is added to water? H3O plus. What will be the conjugate base of water? Remove a proton out of it so that it is converted to OH minus. NH3. What will be the conjugate acid of it? Add H plus to it. You get NH4 plus. What will be the conjugate base of it? Remove a 1 H plus out of it. So eta jodi H yar pra komai diu, then it will be NH2. Aru neutral opa jodi eta plus komai diu, then it will be minus. Are you understanding this thing? Just tell me.
Yes, sir.
Bisulfate ion, HSO4 minus. What will be its conjugate acid? Tell me.
H2SO4.
H2SO4. And what will be the conjugate base of it?
So SO4 2 minus.
Very good. SO4 twice minus sulfate ion. তো গোটেই কেইটা এক্সাম্পল মই যিখিনি দিছো আমি দুয়োফালে মুভ কৰিব পাৰিছো, সবৰ কাৰণে হয়তো এটো সম্ভৱ নহয়, বাট যেহেতু এইকেইটাৰ কাৰণে সম্ভৱ হয়, তো all these molecules or ions at the middle have both conjugate acid as well as conjugate base of it. So such substances are referred to as amphoteric substances. Amphoteric substances. So according to Arrhenius concept, amphoteric substances can lose proton as well as OH minus. According to Bronsted Lowry concept, amphoteric substances have both conjugate acid as well as conjugate base. So that is how we can say that Bronsted Lowry concept mote more number of molecules and ions can be now classified as acids, bases, and amphoteric substances. Understood?
Yes, sir.
Now, one thing that you must be very much clear is in a conjugate acid base pair, you first write it down. Have you completed writing this much?
Yes, sir.
Okay. So at a conjugate acid base pair or jodi one of them is strong, then its conjugate pair will be weak. What does that mean? If Bronsted acid is a strong acid, if Bronsted acid is a strong acid, then its conjugate base is weak. In a pair, both cannot be strong or both cannot be weak. If one is strong, the other has to be weak, and vice versa. Say, for example, HCl is a strong acid, but Cl minus is a weak base. Similarly, CH3COOH is a weak acid, but CH3CO minus is a strong base. So if one is strong, then its conjugate pair has to be weak. If one is weak, then its conjugate pair has to be strong. Both cannot be strong or both cannot be weak. That is the important characteristic of conjugate acid base pair. Clear or not?
Yes, sir.
Others, is it understood?
Yes, sir.
No. So I'm giving you a task to do at home. Just now I have explained you some of them. You can find it out yourself. The question is, for each of the following, find the corresponding conjugate acid and base. Okay, so all these are amphoteric by amphoprotic substances. That is why all of them have both conjugate acid as well as conjugate base possible. So what you are supposed to do is you have to calculate. Water I have already shown. HCO3 minus, HSO4 minus, this also I showed. NH3. So most of them I have shown. So how you are going to get conjugate acid of it? Add H plus, conjugate base of it, subtract H plus. Okay, so this one and this one I have already shown. Only HCO3 minus is left, so that you can simply tell me what will be the conjugate acid of HCO3 minus. Tell me.
H2CO3 plus.
H2CO3. No, there will be no plus, because if you add H plus, the minus and plus will mutually get neutralized. So what will be the conjugate acid? Only H2CO3. Okay. There will be no charge. And what will be the conjugate base of it?
So
CO3 2 minus, isn't it? Carbonate ion. Understood? Yes, is it clear or not, everyone?
Yes, sir. Clear.
Shall I proceed? Yes, can I proceed?
Yes,
I
sir.
think I'm audible. So A to whole Bronsted Lowry concept, the second concept. Now let us move on to the third and final concept, which takes into consideration more number of molecules and ions, as acids and bases. And what is that? Number 3, Lewis concept. Lewis concept. So let us see that according to definition of Lewis concept, what is an acid or a base? It is also referred to as electronic concept. The definition has been given in terms of electron accepting and electron donating. So according to this concept, acid is a substance that accepts electron pair. তার মানে যোনে ইলেক্ট্ৰন পেয়াৰ বেলেগৰ পৰা একসেপ্ট কৰে সিহঁতক আমি লুইস এসিড বুলি কওঁ. Base is a substance that donate electron pair. So ultimately, according to Lewis concept, if we see what is an acid-base reaction, it is transfer of electron from one substance to another. Hence, an acid-base reaction involves transfer of electron from a base to an acid. So eta base electron donate কৰিব পাৰে electron pair, এটা acid electron accept কৰিব পাৰে. গতিকে Lewis concept মতে what is an acid base reaction? It is transfer of electron from a base to acid. So if say this is an acid and this is a base, so if the base donates a pair of electron to acid, then it is going to form a coordinate covalent bond, which we have learned in chemical bonding chapter. It's a special kind of bond where both the electrons are coming from one of the atoms. So thus we can say this is a Lewis base. Why? Because it is donating a pair of electrons. And this is Lewis acid. Why? Because it is accepting a pair of electrons. So in order to be Lewis acid, the substance must be electron deficient. And in order to be a Lewis base, the substance must be electron rich, because then only it can think of donating a pair of electrons. So Lewis acids are electron deficient species. Okay, so all positively charged species that are capable of accepting electron pair, whereas Lewis bases are electron rich species. Lewis bases are electron rich species. Okay, is it understood?
Yes, sir.
আচ্ছা, সদায় যে লুইস অ্যাসিড হবলে পজিটিভ চার্জে হব লাগিব তেনেকুৱা কোনো কথা নাই। Even if the substance is neutral, but the central atom has incomplete octet, then also it can act as Lewis acid. So say for example, neutral species such as AlCl3, BeCl2, BCl3, etc. act as Lewis acids due to the electron deficient centers in them. So you see that none of them have any positive charge on them. Positive charge 9. Tothapiu, they can accept a pair of electrons. Why? Because they have incomplete octet. So in chemical bonding chapter, we have discussed some electron deficient compound where the central atom has incomplete octet. So all such species, in spite of the fact that they do not possess any positive charge on them, into incomplete octet hoar karone, they can act as electron acceptors. So ঠিক তেনেকুৱাকে base হবলে it is not necessary that they should be negatively charged only. Even the neutral species can act as Lewis base. Neutral species such as NH3, ROH, ROH মানে alcohol, water. So none of them have negative charge on them, but still they can donate a pair of electrons because they have lone pair of electrons, etc. are Lewis bases as they have lone pair of electrons on the central atom. So central atom or oporot jehetu lone pair of electrons ase, gotike they can act as Lewis bases. So it is not a hard and fast rule that in order to be an electron acceptor, you must possess always positive charge. Positive charge na thakileo you can act as acceptor provided you have deficiency either due to incomplete octet or sometimes you may be surrounded by highly electronegative atom which makes you electron deficient. So all these are, to tar mane Lewis concept mote maximum number of molecules or ions could be categorized as acid or base. Arrhenius concept mote it was limited because according to the definition, যদি H plus আছে তেতিয়া হলেহে তুমি অ্যাসিড হবা, যদি OH minus দিব পারা তেতিয়া হলেহে তুমি বেস হবা। বাট ব্রনস্টেড কনসেপ্ট মতে বেসৰ ডেফিনেশন টু চেঞ্জ হৈছে। তো গুটেইখিনি আমি যদি একেলগে ডেফিনেশন কেটা লিখি দিব পাৰো, then it will be easier for us to understand the whole concept. Arrhenius concept Bronsted Lowry concept. Lewis concept. Acids, bases. So according to Arrhenius concept, what are acids? H plus donors in aqueous solution. Aqueous solution is mandatory. Bases, OH minus ions donors in aqueous solution. Bronsted Lowry concept. What are acids? H plus ion donors. So here aqueous solution may or may not be there. Bases, H plus ion acceptors. Lewis concept. What are acids? Electron pair acceptors. What are bases? Electron pair donors. So when all together, all the three classifications are given, it will be easier for us to compare that what is the difference between the different ways of classification. I hope this much is clear to all of you.
Yes, sir.
Okay. ঠিক আছে, so এইখিনি মনত ৰাখিবা according to the acid base concept. আজি আমি কেইটামান important concept কৰিলো, electrolytes or বিষয়ে প্ৰথম discuss কৰিলো, classification of electrolytes into strong and weak, and we saw that equilibrium is established only in weak counterparts, and thereafter we discussed about different concepts of acids and base. From time to time it was changed, starting from Arrhenius concept to Bronsted Lowry concept and finally to Lewis concept. So next day we'll continue further with some questions based on the acidic nature, and we are going to discuss a very important topic, that is pH. Okay, so thank you, good night all of you, take care.
Thank you.